Article 310.15 of the National Electrical Code addresses the installation of conductors, stating that conductors shall not be installed in a manner in which they can rub together or contact surfaces with sharp edges. Now let's consider a situation with two groups of wires. The first consists of two sets of 12mm2 cables, which equals 4 number 12 American wire gauge conductors. The second group has three sets of 40mm2 cables totaling 6 number 14 American wire gauge conductors. These wires are installed in a 1 and 1/8 inch bored hole through three top plates, creating a 4-inch wire run. The authority having jurisdiction, or OJ, is citing Article 310.15 because they believe the wires are rubbing together or contacting sharp edges within the bored hole. This situation can create several hazards. Firstly, it can lead to insulation damage, as the constant rubbing against wood or other wires can wear down the protective layer. Secondly, it can cause an electrical short circuit, which happens when damaged insulation allows conductors to come into contact, leading to unintended current flow. Thirdly, the situation can even present a fire hazard, especially if the short circuit generates excessive heat. From the perspective of the installer, there may be a belief that the authority having jurisdiction is mistaken and that the wires are not contacting sharp edges. However, it is important to acknowledge that the authority having jurisdiction has the authority to make interpretations of the National Electrical Code. When faced with such a situation, it is best to consider possible solutions to address the concerns raised by the authority having jurisdiction. Firstly, carefully inspect the hole. Examine the bored hole for any sharp edges or protrusions that could potentially damage the wires. This inspection should be thorough, checking for splinters, rough spots, or improperly drilled sections that could pose a threat to the wire insulation. Secondly, use wire protectors. Install bushings or grommets inside the hole to prevent the wires from rubbing against sharp edges. Bushings are typically plastic or rubber inserts that line the hole, creating a smooth surface for the wires to pass through. Grommets serve a similar purpose, providing a protective barrier between the wires and the wood. Thirdly, reroute the wires if necessary. Consider rerouting the wires through a different path that avoids sharp edges. This might involve drilling a new hole in a different location or utilizing an existing pathway that offers better protection. When rerouting, ensure that the new path complies with all relevant codes and regulations. It is important to comply with the requirements set by the authority having jurisdiction, even if you disagree with their interpretation. By addressing the authority having jurisdiction's concerns, you can ensure the safety and code compliance of your electrical installation. Taking these steps demonstrates a commitment to safety and professionalism, fostering a positive working relationship with the inspector. When dealing with electrical installations, remember that safety should always be the top priority. Even if you believe the installation is safe, it is essential to address the concerns of the authority having jurisdiction to avoid potential hazards. By following the recommendations outlined here, you can ensure that your electrical installations are both safe and compliant with the National Electrical Code. The key takeaway is that the National Electrical Code aims to prevent conditions that could lead to insulation damage, short circuits, or fires. When conductors pass through wood or other materials, they must be protected from abrasion and sharp edges. Addressing potential issues proactively can prevent problems down the line and ensure a safe and reliable electrical system. Let's explore some specific details regarding the conductor fill and derriting. When multiple conductors are installed in a single raceway or cable, like the bored hole in this scenario, the National Electrical Code requires that the ampacity of the conductors be derrated. This derrating accounts for the heat generated by multiple current-carrying conductors in close proximity. If the number of current-carrying conductors exceeds 3, the ampacity of each conductor must be reduced according to a table in the National Electrical Code, typically Table 310.15 current. The derrating factors vary depending on the number of conductors. For example, if there are 4 to 6 current-carrying conductors, the ampacity is derrated to 80%. If there are 7 to 9, it is derrated to 70%, and so on. In the case of the two 12mm2 cables and three 40mm2 cables, we need to determine the number of current-carrying conductors. Each 12-2 cable has two current-carrying conductors, the hot and neutral, while the ground wire is not considered a current-carrying conductor for dating purposes. Similarly, each 14-2 cable has two current-carrying conductors. Therefore, there are a total of 4 current-carrying conductors from the 12-2 cables and 6 current-carrying conductors from the 14-2 cables, resulting in a total of 10 current-carrying conductors. With 10 current-carrying conductors in the board hole, the ampacity of each conductor must be derated to 50% according to the National Electrical Code table. This means that the number 12 American wire gauge conductors, which typically have an ampacity of 20 amps, must be derated to 10 amps. Similarly, the number 14 American wire gauge conductors, which typically have an ampacity of 15 amps, must be derated to 7.5 amps. It's crucial to ensure that the loads connected to these circuits do not exceed the derated ampacity values. If the loads exceed the derated ampacity, the conductors could overheat, leading to insulation damage, short circuits, or even fires. The size of the bored hole is also relevant to the National Electrical Code requirements. The National Electrical Code specifies the maximum number of conductors that can be installed in a raceway or cable based on the fill percentage. The fill percentage is the ratio of the total cross-sectional area of the conductors to the cross-sectional area of the raceway or cable. The National Electrical Code provides tables that specify the maximum fill percentages for different types of raceways and cables. In the case of a bored hole through wood, the National Electrical Code typically treats it as a raceway. The fill percentage must be calculated to ensure that the conductors do not exceed the maximum allowable fill. To calculate the fill percentage, you need to determine the cross-sectional area of each conductor and the cross-sectional area of the bored hole. The cross-sectional area of a conductor can be found in the National Electrical Code tables or calculated using the conductor's diameter. The cross-sectional area of the bored hole can be calculated using the formula for the area of a circle, which is pi times the radius squared. Once you have the cross-sectional areas, you can calculate the fill percentage by dividing the total cross-sectional area of the conductors by the cross-sectional area of the bored hole and multiplying by 100. If the fill percentage exceeds the maximum allowable percentage specified in the National Electrical Code, you may need to increase the size of the bored hole or reduce the number of conductors. It's also worth noting that the National Electrical Code requires that conductors be protected from physical damage. This means that the conductors must be installed in a way that prevents them from being exposed to impacts, abrasion, or other hazards. In the case of a bored hole through wood, the conductors may be vulnerable to physical damage from nails, screws, or other objects. To protect the conductors from physical damage, you can install a metal sleeve or conduit inside the bored hole. The metal sleeve or conduit will provide a barrier between the conductors and the surrounding wood, preventing damage from external sources. Another option is to use a cable with a metal jacket such as armored cable or metal-clad cable. These cables have a layer of metal armor that protects the conductors from physical damage. When installing conductors in a bored hole, it's also important to ensure that the conductors are properly supported. The National Electrical Code requires that conductors be supported at intervals that prevent them from sagging or becoming damaged. In the case of a bored hole through wood, you can use cable ties or staples to support the conductors. The cable ties or staples should be installed in a way that does not damage the conductor insulation. In addition to the National Electrical Code requirements, it's also important to follow any local codes or regulations that may apply. Local codes may have additional requirements for electrical installations that are not covered by the National Electrical Code. It's always a good idea to check with your local building department or electrical inspector to ensure that your installation complies with all applicable codes and regulations. When dealing with electrical installations, it's important to have a thorough understanding of the National Electrical Code and any applicable local codes. If you are not familiar with these codes, it's best to consult with a qualified electrician. A qualified electrician can ensure that your installation is safe and compliant with all applicable codes and regulations. They can also provide guidance on the best way to address any concerns raised by the authority having jurisdiction. Remember that electrical work can be dangerous, and it's always best to err on the side of caution. If you are not comfortable working with electricity, it's best to leave the work to a qualified professional. Working with electricity requires specialized knowledge and skills, and it's important to take the necessary precautions to protect yourself and others from harm. When planning an electrical installation, it's important to consider the long-term implications of your decisions. The electrical system should be designed to meet your current needs and also to accommodate future growth. This may involve installing larger conductors or raceways than are currently required to allow for future expansion. It's also important to choose high-quality materials and components that will last for many years. Sheet materials may save you money in the short term, but they may also fail prematurely, leading to costly repairs or replacements. By investing in high-quality materials, you can ensure that your electrical system will be reliable and durable for many years to come. When selecting conductors for an electrical installation, it's important to consider the ampacity of the conductors. The ampacity is the maximum amount of current that a conductor can carry safely without overheating. The ampacity of a conductor depends on several factors, including the size of the conductor, the insulation type, and the ambient temperature. The National Electrical Code provides tables that specify the ampacity of different types of conductors under various conditions. It's important to choose conductors with an ampacity that is sufficient to handle the load that will be connected to the circuit. If the conductors are too small, they could overheat and cause a fire. When installing conductors, it's important to follow the manufacturer's instructions and the National Electrical Code requirements. The conductors should be properly terminated and secured to prevent them from coming loose or becoming damaged. The insulation should be protected from abrasion and physical damage. The conductors should be supported at intervals that prevent them from sagging or becoming damaged. By following these guidelines, you can ensure that your electrical installation is safe and reliable. Finally, remember that electrical safety is everyone's responsibility. If you see something that doesn't look right, don't hesitate to report it to a qualified electrician or your local building department. By working together, we can create a safer environment for everyone. In summary, when running wires through bored holes in wood framing, several factors must be considered to comply with the National Electrical Code and ensure safe electrical installation. These include protecting the wires from sharp edges, directing the ampacity of the conductors due to bundling, ensuring the hole size is appropriate for the number of conductors, protecting the wires from physical damage, and properly supporting the conductors. Addressing these concerns proactively will help prevent potential issues and maintain a safer and reliable electrical system.